All right, let's dive right in. We're going to explore some incredible science you can unleash, like right in your own kitchen. We're talking about using everyday items to get some truly mind-blowing results.
You know, some of the most mind-bending effects you've ever seen, they aren't really magic tricks at all. They're just science wearing a disguise. And what I love about science is that it's like magic, except it's real. Okay, so take this classic experiment. How is this even possible? I mean, it looks like it completely defies logic, right? You're watching a hard-boiled egg that is clearly way too big for the opening just get sucked right inside. The secret, though, it's not magic, it's air pressure. So, as the science communicator Mark Rober shows, the trick is actually pretty simple. First, you heat up the air inside the bottle, maybe with a little piece of flaming paper. Then, you place the egg on top, which cuts off the oxygen so the flame goes out. Now the air inside starts to cool down. As that hot air cools, it shrinks, it contracts, and that creates a pressure difference. You get lower pressure inside the bottle and higher pressure outside. And that higher pressure on the outside is what literally pushes the egg right into the bottle.
And this whole idea of invisible forces applies to so many simple experiments. For instance, if you drop a few raisins into a glass of fizzy water, you can actually watch them dance. The carbon dioxide bubbles stick to them and act like tiny little life jackets, lifting them up to the surface. But once they get to the top, the bubbles pop, and the raisins sink all the way back down again, and the whole thing just keeps repeating in this awesome, mesmerizing dance.
Now what's really interesting is that sometimes the trick isn't happening in the bottle or in the glass. Sometimes it's happening inside your own head. So let's take a look at how easily your own brain can be tricked. You should totally try this one right now. It's a super simple but pretty incredible optical illusion that reveals something amazing about how you see the world. If you just follow these steps and make sure you keep both of your eyes open while looking straight ahead, a hole should appear, like magic, right in the middle of your hand.
So what in the world is going on? Well, the really crucial point here is that you aren't just seeing with your eyes. No, you're actually seeing with your brain. Your brain is constantly, every second, working to process two slightly different pictures, one from each of your eyes, and its job is to merge them together into one seamless image. And this quote explains exactly what's happening. See, in this little experiment, you're giving your brain a totally unnatural situation. One eye sees your hand, and the other eye sees this limited view through the paper tube. The only way your brain can possibly make sense of these conflicting images is to just combine them. And the result is you seeing a hole straight through your hand.
Okay, let's jump back for a second to another one of those magic tricks we talked about, the floating lemon. The science here isn't in your brain, it's in a property called density. At first, the lemon is denser than the top water, which is why it sinks. But when you start adding salt, you're not changing the lemon at all. You're changing the water. You're making it denser. And as soon as that salt water becomes denser than the lemon, well, the lemon has no choice but to float.
So now let's see how these simple principles can really build, because the same science that you can play with in your kitchen can be scaled up for some truly spectacular, and I mean spectacular, results.
A perfect example of this is the elephant's toothpaste reaction. The at-home version is pretty tame. It just uses yeast and some weak hydrogen peroxide, and you get a nice, gentle fizz. But change the variables, use a way more powerful catalyst like potassium iodide and concentrated peroxide, and what you get is an enormous exothermic reaction that shoots out a huge amount of heat and foam.
And this is exactly what programs like Fun with Chemistry at Rice University do. They use these amazing sights like hydrogen balloon fireworks and liquid nitrogen thunderclouds to inspire students and show them just how dynamic and exciting science can really be.
Now, before you try any of these things, it is absolutely critical that we talk about safety. Because here's the thing, being a good scientist means being a safe scientist. Take dry ice. It's amazing stuff, but it is extremely cold. We're talking negative 109.3 degrees Fahrenheit. And it's constantly releasing carbon dioxide gas. So that means you have to handle it with insulated gloves, you have to use it in a well-ventilated space, and you should never ever put it in a sealed container because the pressure buildup could cause it to explode.
And for any experiment that involves fire or chemicals or any potentially dangerous reactions, adult supervision is not just a suggestion. It is an absolute requirement. Safety always comes first.
So why is making slime and erupting foam so important? I mean, it's fun, but why does it matter? Well, it turns out this kind of fun is actually essential. It's about so much more than just a cool reaction. It's about inspiring the future.
So why does this matter? Well, according to research, the United States currently ranks 44th in the world for the quality of its STEM education. 44th. That's why getting students engaged in science, technology, engineering, and math isn't just for fun, it's basically a national priority.
You know, the old chalk and talk method of teaching, it just isn't enough anymore. As this report points out, when science is just a series of formulas on a blackboard, it can feel really boring and completely disconnected from the real world. These hands-on demonstrations are what spark real curiosity. They make science something you can actually touch and see. But more than that, they teach the core of scientific thinking: how to observe, how to ask questions, and how to understand cause and effect. They show all students, including young girls who are often underrepresented in these fields, that science is absolutely for them.
So really, the big takeaway is to just stay curious. Mark Rober puts it perfectly. The most important words in science are not eureka. They're "that's interesting," because that's the starting point for every great discovery. So ask questions, experiment safely, and never, ever stop exploring. What will you discover?